right, so let's talk about some word problems involving volume. So the first one, we're given the dimensions of a brick. One important thing to know is it is in inches, and we need to figure out how many bricks it takes for 1 cubic foot. So in order for us to figure out the answer to this question, ultimately I can look at this as the total volume divided by the volume of 1 brick. So the things I need to know are the total volume, and I'm going to divide that by the volume of 1 brick. So 1 cubic foot, I'm just going to label it TV for total volume. So 1 cubic foot would be 1 foot by 1 foot by 1 foot, but I can't do feet and inches. So the easiest thing to do is convert the feet into inches and go from there. So that would be 12 inches times 12 inches times 12 inches. And this will give me cubic inches instead of cubic feet. And that's 1,728 cubic inches. And I'm going to do the same thing for 1 brick. And it's 2 by 4 by 8, which gives me 64 cubic inches. And then I'm going to take 1,728 divided by 64. That tells me we would need 27 bricks. And I did all of that using my calculator. Next one we're going to look at here, we have a carryout container. It gave us the picture, this little trapezoid contraption here, and our goal is to figure out the volume. Now you can do one of two things. You can use the area of a trapezoid formula and then multiply it by the depth of the box, or you can split it up into a rectangular prism, which would be this space in here. So I can take out this centerpiece, and then I'll have 2 of these triangular prisms on the edges. I'm going to do it that way, the second way, and I'm going to draw 2 pictures to help us see this. So my rectangular prism, actually in this case, how are my drawing skills today? Hey, not that bad. All right, so we have 4 being our base, 4 being our depth, and 5 being our height. So the volume of this would be 4, not times 8, 4 times 4 times 5, which is going to give us 80 cubic inches, right? Yeah. And now the nice thing about this, these 2 triangular prisms are going to be identical. So I'm going to do the same thing here, find the volume of my triangular prism, and then I'm going to just multiply that by 2 because I'm going to have 2 of the exact same thing. So drawing myself a picture, maybe. All right, so here, hey, that's not half bad. So I've got 2 of these, just keeping that in mind, and they're identical. Now they have a height of 5, a depth of 4, but I need to figure out the width. Now this is 6 inches total across on the top. I've taken 4 inches away, and I have to evenly split that in half. So really, I'm doing 6 minus 4 divided by 2. Well, that's 2 divided by 2. So each of these are a space of 1 as the width. So I have 2 of this 5 times 4 times 1 divided by 2, and that's just my triangular prism formula. Well, 5 times 4 is 20, divided by 2 is 10, or you could also see that I am multiplying and dividing by 2. Either way you want to slice it or dice it. This is 20 cubic inches. Adding those two things together gives me 100 cubic inches. All right, we got 2 more. So we have a rubber ball. We know the circumference of the rubber ball. We want to get a gift box that we can put this rubber ball inside, but there's only cube-sized boxes with 3, 4, 5, or 6 inches as the sides. And we need to figure out the smallest size box we could purchase to make this fit. So, just so that we know what's going on picture-wise, I'm going to try really hard to make this work. I have zero faith in my art skills for making this pretty by any means. So here's this box, and our goal is to put this ball inside of it. Oop. Hey, that's not half bad. All right, so one thing I need to know is I need to know the diameter of the ball. Because if I know the diameter of the ball, I can figure out however tall or wide or deep the ball needs to be, because I'm putting this ball inside of the box, and the box has to fit the diameter of the ball. So I need to know the diameter. That's my goal. Well, in order to find the diameter, I do have the circumference. And remember, the circumference is 2 pi times the radius. I know the circumference is 13 inches. And if you're like me and you want to just put everything into your calculator at once, I'm going to divide by 2 pi on both sides. So my radius is equal to 13 divided by 2 pi, which my calculator can take care of for me. And that's about 2.07 inches. Since my radius is twice the diameter, I'm going to take this and multiply it by 2. And my diameter is 4.14 inches, or thereabout. So in order to fit the ball with a diameter of 4 inches in one of these 4 boxes, 3 is definitely too small. 4 inches is too small because my diameter is over 4 inches. So we would need the 5-inch box in order to fit the ball inside of it. And that's the smallest one that we could use. All right. Now we have a rectangular container that's going to get filled with cups of water. And we have to figure out the maximum number of cups that we could put into the box or the container without it overflowing. So I need to take the volume of the rectangular container, and I need to divide that by the volume of the cup, and that's going to tell me how many cups the container could hold. So the volume of the rectangle, or the rectangular container, I should say, it's 10 inches by 15 inches by 20 inches. So I'm just going to multiply 10 by 15 by 20. Which is going to give me 3,000 cubic inches. The volume of the cup, since it's a cylindrical cup, I need the cylindrical volume formula, which is pi r squared times height. The radius is 2, so I'm going to square 2, and the height is 5. And I would just put it in my calculator, literally exactly like that, parentheses and all. And this is about 62.83 cubic inches. And I'm literally just dividing those two numbers. Now this will be a number that is 47 point whatever the decimal was. I did not write that part down ahead of time. That extra decimal part of a cup can't be part of my answer because they want full cups of water, not partial cups of water. So I could only use 47 full cups. The 48th cup is going to overflow this container.